Hey y'all, for the first time in video format, this is Mrs. Power, here to help you with your Module 3 exam review. I've made up the review, I've made up the tests, and we're just going to do the review on this video. We'll do it together. We'll also do it in class on Tuesday before your test on Wednesday. If you have any questions over the weekend, you can email me or you can ask them on Tuesday when we do the review in class. Let's get to it. I am going to use non-Halloween colors now since it's Christmas. Okay. Complete the table. Leave your answer in radical form. Write the explicit equation below. This is for an exponential equation. I'll write that in before I post it. So for exponential equations, we know that we multiply by the same thing every time we move up by a whole number. So here, when I go from 12 to 36, I can do in my calculator, 36 divided by 12 is equal to 3, so I must have multiplied by 3. To finish out this table, for all the whole numbers, I will multiply by 3 again and get 108. And then to go backwards, I divide by 3 and get that I started with 4 bacteria. In order to do the half steps, right, in order to go from 1 to 1.5 or from 2 to 2.5, I don't multiply by 3. I multiply by the square root of 3. So I just write 36 root 3, 12 root 3, and 4 root 3. The reason is, if I break multiplication up into two parts, I would break it into its two square roots. And then the final part of this question says to write the explicit equation for this scenario. The explicit equation for an exponential is always the starting point, aka what we had here at hour 0, multiplied by our ratio to the power of x. Now we're going to simplify some radicals. Simplify the followings. Answers should be in radical form. Whenever we have a number that we're simplifying, the first thing we do is break it up into its prime factorization. We do this by taking any two numbers that can multiply to this number. So 42 looks divisible by 2. I do 42 divided by 2, I get 21. 21 is 3 times 7. Oh, this is a terrible example because it's actually already simplified. Hilarious. It breaks up into its prime factors. Whenever we've got 2 times 3 times 7, there are no pairs, so this is actually already simplified. If we did something better, what would be a better example? 72, right? And I'll make the review say 72 instead. We would break this into 8 times 9. 8 is 2 times 4 and 2 times 2. 9 is 3 times 3. So 72 becomes 2 times 2 times 2 times 3 times 3. We bring pairs out front. We leave the leftover square root of 2 in the back. And our final answer is 6 root 2. Pretty good. All right, when we have the cube root, instead of looking for pairs, we'll look for groups of 3. Same thing here. We want to break this into as many pieces as possible. And we do this by saying 625 looks like it can divide by 5. I do it on a calculator to get that it's 125. 125 looks like it can divide by 5. I get 25. And now I break that into 2 5s as well. I then get that there are 4 5s and 7 x's. And we're looking for pairs of 3. If we're looking for pairs of 3, and we've got 4 5s, that's one pair of 3 with 1 left over. So the 1 5 comes out front. The 1 5 gets left over. If we've got 7 x's, that is 2 pairs of 3 with 1 left over. So we bring out our 2 pairs with our 1 left over. And that's our final answer. Nice. Whenever we have an exponent to another exponent, we just get to multiply them, right? So this becomes x to the 24 times 1/3 times y to the negative 12th times 1/3. 24 times 1/3 is 8. Negative 12 times 1/3 is negative 4. And then, as always, if we've got a negative, we would put it on the bottom or switch its side. We could have thought about this as 24 y to the negative 12 to the third root, because 1/3 is the third root. We then could have moved the y stuff to the bottom and kept going from there. Either way works. Here, 196 is 14 squared. So if you know that it's a perfect square, we can just turn it into 14. Otherwise, we would want to divide by, 2 and get 196 divided by 2, get 98. 98 divided by 2 is 49. This is 7 and 7. Then the square root of 2 times 2 times 7 times 7 is just 2 times 7, which is 14. The square root of k to the 12th will be k to the 6th, because when we square root, we can either say 12 things is 6 pairs, or we can just divide it in half. So this we can divide in half, and this we can divide in half, giving us our final answer. Nice. Let's keep going. Number 3. When we've got exponents to the power of other exponents, we multiply those exponents. So we do negative 3 times 5, get negative 15. Negative 4 times negative 3 is positive 12. The things inside of these parentheses are already simplified because their bases don't match. And now when we're multiplying all of these things, we add their exponents. So we get negative 3 and 17, because negative 15 plus 12 is negative 3, and 12 plus 5 is 17. My final answer should have only positive exponents, so I will move my negative exponent to the denominator. I think I'm going to need more room for this one, so let's move this over. For this one, same thing we did over here. We need to do on both the numerator and denominator. We need to multiply these exponents to get rid of this outer exponent, and multiply these exponents to get rid of this outer exponent. This z has no exponent, so we treat it like it has a 1. Now, when we're dividing, we subtract. 6 minus 56 is negative 50. 10 minus 14 is negative 4. And 6 minus 7 is negative 1. When we've got negative exponents, we move them to the denominator or to the opposite side. And when there's nothing else on top, we put a 1. Nice. For this one, we can add the 3 to the 4th and 3 to the 2nd exponents to get 3 to the 6th. Right. Because they're the same base. And then we can move the 4 to the negative 2 to the denominator and make it have a positive exponent. That would be our final answer there. Great. For number 4, we want to solve using the method listed. When we want to use factoring, right? This is when we say what multiplies to negative 30 and adds to negative 13. I'm going to go with 15 and 2 because they equal 30 and they're 13 apart. And then I know this one should be the negative because when I'm adding, I want the bigger one to be negative, so my answer is negative. I then just get to write x minus 15, x plus 2, and we're done. Psych! You are not finished here, right? The instructions say solve the quadratic, So my answers will be x equals 2 numbers. The way I get those numbers is from the factored form, but I'm not just finished when my factored form is finished, right? Or not finished. So I set each of these equal to 0 and solve for x in order to find my actual answer. This is the answer. Nice. For number 2 and 3, I want you to use either the vertex form or the quadratic equation. I'll do one of each, just for fun. Oh my god, this is actually going to be awful in vertex form. I'll do it anyways. For the vertex form, we write out our pattern. I'm going to divide this number by b and also by 2. Sorry, by a and also by 2, but there's no a. So I just do 5 divided by 2. I then square that number. That number squared is 2.5 times 2.5, 6.25. And then to get this number, I do 7 minus 6.25 and get 0.75. I'm not finished. Now I want to solve for x. So I subtract 0.75 from both sides. I'm actually immediately going to change all these into fractions. No, I won't. I get x plus 2.5 squared equals negative 0.75. I square root both sides, remembering to add in a plus or minus when I square root things. The square root of negative 0.75 is whatever the square root of 0.75 is times I. So let's do that. 0.75 square rooted. Wow, that's terrible. We'll call it 8.6 or 0.86. And then I subtract 2.5 from both sides to get x equals negative 2.5 plus or minus 0.86i. And that will be my final answer. To be honest, the ones in your test won't look this gross. But the main point is if you have a square root of a negative number, that means we're going to have i's in our answer, which is totally fine now. This one I will use the quadratic formula for. Here my a is 2, my b is negative 4, and my c is negative 3. My quadratic equation is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I get the negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 3, all divided by 2 times 2. The negative b for a negative b is going to be positive. Negative 4 squared is still positive 16. I multiply all these together and get 24. 16 plus 24 is 40. 40 is 2 square roots of 10. Because over here, I can break this into 20 and 10 and 2 and 2 and 5. And there's only one group of 2 out front. Then when I divide all these by 4, 4 divided by 4 is 1, and 2 divided by 4 is 1/2. These being my 2 answers. Number 4, it says use any method. This is going to be one that's slightly harder to factor than maybe some other ones. So you can factor, but you can also use the quadratic function, of course. When we factor this, we can use the Xbox method, where we multiply a and c. We try to add to 11. We get 6 and 5. The box then becomes, we rewrite 2x squared, we rewrite 15. We use the 6 and the 5 from the x to write in 6x and 5x. And then we find the common factor for all of these, giving us 2x plus 5, x plus 3. I'm not finished yet. I now need to set this equal to 0 and set this equal to 0 in order to find my two answers. 2x plus 5 equals 0 means 2x equals negative 5, which means x is negative 5 halves. And then this being 0 just means x is negative 3. Well, that's just not intelligible. My two answers here are negative 3 and negative 5 halves. For number 5, determine the classification of the roots of the following quadratics without fully solving them using the discriminant. The discriminant is all the stuff underneath the square root for the quadratic formula. Your answer should be one of the following. Imaginary, that's when our answer is negative. Rational, that's when our answer is positive and a perfect square. Or irrational, that's when our answer is positive and not a perfect square. Let's do it. For b squared minus 4ac here, our b is negative 3, our a is 9, and our c is 2. This is 9 minus 72, which is negative 63. This is a negative number, so our roots will have imaginary components to them. For this one, when we do b squared minus 4ac, we get negative 7 squared minus 4 times 6 times 3. This is 49 minus... And these were silly questions to do, that's fine. 4 times 3 is 12, times 6 is 72. And 49 minus 72 is negative 23, which again will give us imaginary numbers since they're negative. For this one, b squared minus 4ac gives us negative 10 squared minus 4 times 2 times negative 5. This is 100 plus 40, because negative 4 times 2 is negative 8, and negative 8 times negative 5 is positive 40. This will give us an irrational answer. Since 140 isn't a perfect square. I'm now realizing that back here, we should have had times negative 3. So this should have been positive 72. And then this becomes 100 and 49 plus 72. Oh, nice. 121, which is a perfect square and is positive. So this actually gives us rational answers. Wow, nice. So even I mess up a lot. The danger is if you have a negative a or a negative c, make sure you eventually get a positive number from that. Nice. Okay, number 6. Given the following roots, write the quadratic equation in factored form that has these roots. This one's kind of easy, I'm not gonna lie. This one, we switch the sign and we're done. Right? Instead of 8, we have negative 8, and instead of negative 2, we've got positive 2. If we want to do stuff like this, we just switch both of the signs. Right? This root gives us this factor because we've had 2 negatives and now it's 2 positives. This root gave us this factor. We had a negative and a positive, and now it's a positive and a negative. Same thing here. Same thing here. If you want bonus points, you would FOIL these, right? But I won't show you that because it's bonus points. You can ask on Tuesday. Solve the following inequality. It's basically the same as solving the equation, but just like with a little extra step at the back. First, I'm going to factor. I'm going to say what multiplies to 32 and adds to 12. That is 8 and 4. I then turn these into their x-intercept form. Now is when I do this number line thing. I say my two x-intercepts, my two places where this actually equals 0, are -8 and -4. And now I want to see, does all of this stuff give us a positive or a negative? Does all of this stuff give us a positive or a negative? And does all of this stuff give us a positive or a negative? And the way I'm going to do that is I'm going to plug in numbers that are in this interval. So I will plug in -10 for all the stuff less than 8. -10 squared plus 12 times -10 plus 32. That's 100 minus 120 plus 32, which is positive 12. So this gave us positive stuff. And I plug in -5. I do -5 squared plus 12 times -5 plus 32. 25 minus 60 plus 32, which is negative, let's see, calculator, 25 plus 32 gives us -3. So this gave us negative numbers. Then when I plug in 0, which is my easiest thing to plug in, and I do it at every given opportunity, I get 32, which is positive. My final answer then is all the stuff that's positive, because my question was asking for things that were bigger than 0. So my final answer is everything below -8, as well as everything above -4. I'm going to make a separate video for problem 8 because we haven't done it yet. So this is all the stuff that is review for us this weekend. And then I'll post a different one for question 8. All right, see y'all soon.